Okay, guys, let's start. First off, thank you all for coming. This is a new season of Infinum iOS talks. This will be held each month on the last Tuesday of each month. So please join us also the next time. One other thing, if you know some good subject that you would like to hear about, or if you want to give a presentation, please feel free to contact us so that we don't have to think about all the time what to do, what people like, because we need your input somehow. You can talk to us, send an email, whatever. Today we will only have two presentations because this will be the first, Reactive VIPER. I will be doing this. It will take a little longer than usual. I will split this into two parts. First part will be theory, and second part I will show you the code example. And then you can ask me questions and we can talk about this. The other presentation will be held by my colleague Vedran over here. He will be talking about result pattern and how you can leverage this to make asynchronous error handling much nicer in your Swift code, of course. Also, at the end of this meeting, we'll have some pizza for you all. And during the discussion, feel free to open the fridge. You have a beer, club mate, whatever. Also, these two topics that I will be covering today, they are fairly complex. And if I go too fast or if I'm boring, you can kind of raise your hand and ask me questions while we go along. Okay, so maybe you can tell from the title or not. Today we'll be talking about functional reactive programming using VIPER as a main architecture when building the iOS app. We'll be talking about our version of VIPER, which is slightly different than the one that you can see on the internet. We kind of adapted to our needs, and this is still work in progress, just to know. So you may ask yourself, why would you want to use these two paradigms? First off, I think that functional reactive programming is kind of a new emerging pattern that you can see it a lot in other languages. And only by that, you can get a sense of if it's a good or bad thing. Also, every major currently known language has some version of Rx implemented. So you have Rx Java, Rx.NET, Rx Scala, and all others. Rx pattern in these languages are implemented pretty similar. So concepts that you learn in one language, you can reuse, I would say, 90% in all other languages. Also, I think that when you're doing functional reactive programming, after you go over this steep learning curve in the beginning, you can reason about your code more easily, at least in my opinion. And today, I would say that iOS applications and all other applications are becoming more and more complex. You have lots of events, lots of asynchronous data calls from the network, UI events. So I think this is kind of a good idea to think about your programming using this pattern. Regarding VIPER, well, I would say that MVC kind of sucks for a big application. It's not that you cannot do anything with MVC, but VIPER is, I would say, maybe a new standard, and then you can build each app like this, and everyone who comes after you will have a sense where to put each part of the code. Of course, VIPER is not perfect, and I will go into details a bit later. But let's start with the basics first. UI ViewController, or UI View, it's a workhorse of iOS development. When you first started building iOS apps, this is the first thing that you would kind of have interaction with. And because it's really tightly coupled to the view, you would naturally put all your code here, like for fetching or data source for tailview view, delegates, and whatever. So it's good for the beginners, but as your app becomes more and more complex, I would say that it's not such a nice example. As I said before, workhorse, I would say it's hard to test, hard to maintain, and not really reusable, in my opinion. That's why after some talk and consideration of other patterns, we try to do VIPER. And this is how we do the apps now. As I said again, we are still kind of developing this all the time, because you would think, okay, this works great, but then you would come to the certain problem and, okay, fuck, I cannot do it with this, or I need to rethink. So it has its plus and the minuses. Basically, I will go through VIPER really quickly because my good friend Damian gave this talk like maybe 2 or 3 iOS talks before. So you can download his presentation if you want more about the details. But basically, I think we can say it's like ViewController split in 4 parts. I will shortly describe these 4 parts. Also, I think it's good for medium to big size applications. I think it has a good separation of responsibility, and because of loosely coupled components, you can mix and match with other parts of your code without too much refactoring. The downside of all of this is it's not a standard architecture provided by Apple, so sometimes you will be fighting the framework, mainly UIKit, while you're building your app. Okay. Just some general intro before we go into the main components. Connection between components is mostly done using protocols. We prefer composition instead of inheritance in most cases, and most of our UI is done in storyboards. But we only lay out the views, we don't do the connections. The connection will be done in code. When I say connection, I mean navigation. And some parts of the code that you cannot do in storyboards, you will do in code. These are 4 main components: view or ViewController, presenter or view model in some other paradigms, interactor, and wireframe. So take a moment here and take a look at this diagram. I stole this from Damian. You can see, okay, now it may seem like a complicated thing, and in the beginning, while you don't wrap your mind around it, it kind of looks silly. But bear with me for a second, I will show you interesting parts. ViewController. ViewController should only know how to lay out itself. It shouldn't contain any business logic, so it should be fairly stupid. But this will give you the advantage that it can be reused on multiple screens, if necessary. Presenter. This will be the meat of your application in most cases. It should contain most of your business logic, and because of that, if you put all the logic for, let's say, providing the data to a certain screen, it will be the least reusable part of everything. Also, it has a reference to the view, interactor, and wireframe. And we could say that it models data received from the interactor, and it's a views delegate, which means it responds to the events provided by a view or ViewController. Interactor usually has the data or knows how to get the data for you. And wireframe, when I say that we don't do connections in storyboards, we do our navigation logic here. So it will know how to navigate to a certain screen, and also it will know how to create other VIPER modules. When I say other VIPER modules, I mean different screens, because each screen is, I would say, in most cases, a separate VIPER module. It will have a view, presenter, interactor, and wireframe, in most cases. So this will be it about VIPER. It was only like a refreshment for you. Let's start with the Rx. I will talk about reactive programming in general, and I will be talking about specifics using RxSwift, because this is the thing that we used mainly. In case you didn't know, first reactive programming library was Rx.net. It was created by Microsoft. It's called functional reactive programming. So we can ask yourself, what is functional reactive programming? Well, functional programming, you all know what it is. It's basically you would have a pure function that takes something as an input, and for that same value will return the same result every time. It will not perform any side effects inside. And of course, you cannot program like this, because a real world is all about side effects. So it doesn't make sense for the most part. Reactive programming, on the other hand, is something that is used to propagate changes of something throughout the system. And then we can kind of use this definition of what the functional reactive programming is. I will just read it for you. We will model user input as a function that changes over time, abstracting away the idea of mutable state. This may seem dumb right now, but when you kind of think about it and when you start working with this, you'll get more sense what it is. Regarding reactive programming, just to give you a quick sample, you're all probably using this if you're using Excel spreadsheets or something. So you can say if you have 3 cells, A, B, and C, and you say that C is a sum of cell A and cell B, anytime any of these cells change, the change will be propagated and C will update itself. This is reactive programming. So, again, why Rx? It's a sweet spot, I would say, between functional and imperative programming world. This is nothing new. Most of the stuff that is about Rx are something that is already being used. The good thing is that it unifies various design patterns inside of the Cocoa or Cocoa Touch. I will reference this a couple of times. It's basically a book about design patterns called Gang of Four, and in that book you have most of the patterns that are used today described. So, Rx on the Cocoa Touch can unify the delegates, callbacks, KVO, notifications, and observer. Of course, I would not say that imperative languages are bad, because if you do it in a smart way, it will allow you to program really near the hardware. So it will give you much better performance in most parts. So this is just a way of thinking, a new way of thinking. When I said declarative style, this is how would I done stuff in RxSwift. Now you will not understand everything, but of course there is some learning curve that you need to learn how to use this. But basically you would say what you want to do instead of how to do it. Okay? RxSwift has 2 modules in Swift. One is core, RxSwift, and other is RxCocoa. RxCocoa will give you something like this. So it's like an extension on UIKit, which will allow you to bind to something or to receive events upon user interaction. Okay. Before I try to explain what observable is, or sequence, I will go over 2 basic design patterns that are needed for this to happen. So, Iterator pattern and observer pattern. You all know these patterns, I'm sure. Maybe you don't know them by this name, but I assure you that you're using these every day. Okay. This is something that you can remember, and when you start doing more and more stuff, it will kind of, you will have an epiphany. Observer and iterator patterns are mathematical duals. This is interesting because this was discovered fairly recently. As you recall, I was talking about this book, Gang of Four, and they never said that these 2 patterns are related in any way, but actually they are, and I will kind of give you explanation a bit later. Let's start with iterator pattern. I will explain iterator pattern, and then I will give you a couple of examples in Swift. So, iterator, pool-based interface. Good for traversing collections. You have a generator, on which you can call next, you pull to get the new data. It can signal you that there is no data, or it can give you an error. And as I said, you are using this every day. So when you do for in or while or whatever loop, behind this, you have a generator which will feed you the next values. The thing to remember about iterator pattern is that it can only give you events synchronously. Okay? Iterator in Swift. So let's say you want to design your own collection type. In Swift, this is a set or collection of protocols. You have these three. This is a pretty complex topic, I would say, so you can definitely read about it. There is a really good book, Advanced Programming in Swift, where you have a detailed explanation for all of these three types. And one thing to note is, I'm not sure, but I think this just changed in Swift 3.0. I'm not sure. I didn't have time to kind of take it off. Basically, when you want to implement your own collection, and if it's pretty simple, you would just adhere to this protocol, collection type. But let's start with the beginning. Generator type. It's a protocol, so when you implement it, it will know how to serve elements. You would need to provide associated type, so which type your element would be, and you will need to implement the function next. SequenceType knows how to create a generator, because you can only use generator once. For every consecutive loop, you need to ask for a new generator. This will know how to create the generators. But as I said before, you would probably use something like this, collection type. So it will allow you repeatable iteration, and you can access the elements via its index. Okay? So let's say you want to have a collection of beers. Like, let's say it's struct, but it can be class, whatever. Then you would say that you adhere to SequenceType protocol. You can, for type alias generator, you can use predefined any generator, which you get for free. So you don't need to implement these lower levels protocols in Swift. There's no magic here. Basically, it will know how to give you, from your collection, how to give you, when you do for or next, how to give you the next value. So that's it. Nothing more about iterator pattern. Pretty simple. Observer pattern. I'm also sure that you're using this. It has a push-based interface. So something will push the new data or new events to you. It's good for your events, but there are a couple of things that's missing. There is no error handling and no way to tell when there is no data. The good thing is it can receive events asynchronously. So this would be observer pattern in Swift. You would create a protocol which will have these two properties, okay? And then you would implement it like this. You can use dynamic properties with will set and did set to notify your observers that there has been change. Okay, so now that we know observer pattern and iterator pattern, let's talk about observables or sequences. As I said before, it's a unification of iterator and observer pattern. Oops, sorry. They can be composed. We already know how to do operations on collections. You all know how to do map, filter, and reduce on an array. You can do the same thing on observable. And the most important thing is the equivalence of observable element to the sequence type in Swift that we talked about before. As I said, maybe it doesn't make sense to you right now, but as you start building stuff, you will kind of get to the grips with this. Okay. Every observable sequence is just a sequence, as I said before. The only difference here is that with observables, you can receive elements asynchronously. And this is important because, as I said before, network requests and all data that will not happen instantly. It has a push interface or callback, like closures or blocks. So it will tell you when there is any new data. And if we can define it via regex, it would be this. So we can have 0 or more next events, followed by error or completed. The thing to note here is that after an error or completed, sequence will no longer be, or observable will no longer be able to produce any new elements until you subscribe to it again. And also, no work will be performed until you subscribe. So this is something that you should kind of remember. Okay. There is lots of stuff that we could do and talk about the observables, but I will go quickly over tips and tricks. And then we'll go to the example where we can actually see what the hell I'm talking about. Okay, read the fucking manual. RxSwift has amazing documentation. It's really good. The documentation is nice. Everything is explained. You have a huge collection of examples for, like, I would say most of the kind of regular cases where you want to use it, and the community is really nice. You can read their GitHub documentation. You can join on Slack channel, ask questions. They will respond. It's really good. Okay. Other thing would be avoid nesting calls. In RxSwift, you don't want to nest calls. You probably want to use predefined operators like map, flat map, reduce, filter to kind of combine multiple observables or like, yeah, multiple observables. Always use Dispose Bag. Dispose Bag is something that when your, let's say, ViewController is deallocated, it will clean all the resources. So at the end of your chain, like let's say you have flat map, reduce, subscribe, blah, 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 in the end, the last statement should be add dispose bag. You don't need to use it necessary, but it's a good practice to kind of always include it. And it's especially necessary if you're using Rx inside table view cells. So cell will get dequeued, and when the cell gets dequeued, you want to basically stop doing the work that you've been doing before. This is really common. So you start typing something, flat map, you use wildcard $0, bam, 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 and then you get source kit has crashed. What to do? The best thing is to start annotating types. So if you have a closure, give the parameter a type. Give them a return type. And then probably the source kit will kind of reboot and it will continue to work in most cases. Until it doesn't. You have to remember that, as we said before, you need to provide a callback, like a closure. So if you have something on self and then you do self again in the closure, you will most likely create a retain cycle. In order to avoid this, if you're not sure if it will create a retain cycle, I would advise to kind of use weak self, and then you would be on the safer side. This is kind of also connected to the previous one. You could use something called a resource count, which you can put in the alloc method of your ViewController or presenter or whatever. And then when you navigate back and forth on the screen where you use Rx, you can print resource count before you came to the screen and after. And then if you go back and forth, and this number just goes up, 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 that means you probably fucked something up, and then you can inspect on this screen to check if everything is okay. Of course, strive to modular systems as pure functions. So to kind of stay in the Rx world as much as possible without doing flags all around. You try to get your data is like derived from previous events or previous data. Yeah, I said this badly, but you'll know what I mean when you start doing this. Okay, this is it mostly because, as I said, you kind of need to start working on this to start appreciate it. Now I will show you resources which you can go to. RxSwift, as I said, README file, documentation, everything. Reactive programming overview, what it is and other stuff. Design patterns in Swift, if you want to deepen your knowledge about this. This is really good inside .NET Reactive Framework. Duality, this is a paper that describes the connection between iterator and observer pattern. It's pretty straightforward, so definitely check this out. And I would say the most interesting thing here is this, Rx Marbles. There's a web page where you have a visual representation of most predefined operators in RxSwift. So reduce, scan, flat map, and then you can move the marbles to see what will be the output. It's really good to if you're not sure how to do it. Also, because Rx, as I said before, it's a big community, and you have lots of other languages to implement this. There is like a resource where you can, based on the questions you ask, it will guide you to which operator do I need to use. How do I use this? Why do I need to use this? It's really interesting. So you can also check this out. And now we can have questions about this, then a little break, and then back to the example.
I have a question as a new guy.
Okay, perfect.
As a new guy, in the beginning when you talked about iterators, you said that every iterator has a generator and something like that.
Generator, yeah.
So
Okay.
does that mean that when you use an iterator, it always generates a new value and instead of fetching it from somewhere?
Okay, you mean when you use it observable in Rx world?
Before observable, you talked about iterators.
It's similar to the iterator and iterable in Java.
Yeah,
Sorry?
exactly the same.
It's the same as iterable and iterator from Java. Iterator is that generator type, and iterable is SequenceType.
So you cannot, if you think about network requests, you cannot fetch it asynchronously. It's like only for, I want to say, something that will happen synchronously. So it's like if you want to pull something from a collection, whether be it array or your own collection or everything, you cannot get the data asynchronously using the iterator pattern like described here. But you can get those that you ask with observables. And when you say if you fetch every time, yes. When you subscribe to something, you have a distinction of hot and cold signals. And when you subscribe to something, it will, if you don't put like share reply or reply lazily, you would start the whole process every time you subscribe. That's why when you bind something to the UI, you either want to use a unit called driver, or you want to have replay, so that for every new subscription, it will not do the whole thing again. It will just provide the less value.
Generally, right now, when you read about MVM, most people use Rx with it.
Okay.
So it kind of goes hand in hand.
Okay.
It's not the same for VIPER.
No.
Why do you think that is, and will that may be the case in the future?
Okay. Very good question. Yeah. I think that MVVM started much sooner than VIPER, and in the MVVM, you need some kind of binding mechanism. So I would not say Rx, but I think it was more likely reactive Cocoa, because in Objective-C you would have only reactive Cocoa before, and it was easier with the macros from the reactive Cocoa to create bindings without the need to have a delegate or like a ping pong input from the user, output from the view model. In VIPER, I think the main issue is that it's a bit complicated, but basically the most funny thing is that it's like MVVM all the way, except you kind of separated the navigation and you have interactor for getting the data. So you kind of have two more components, and many more people are using MVVM than it's using VIPER, because if you know, when we look through the internet, there is not so much good articles about VIPER and how to solve all the cases and how to, I don't know, combine all the components to work nicely without causing the retain cycles and everything when you, yeah, I don't know if I...
One more thing. A lot of people have a problem with VIPER because it has a lot of layers communicating, you know.
Yep, yeah, I agree.
Information needs to travel through multiple layers. And Rx is good if you have two things communicating. Would Rx help us in this situation, or?
I think it would. I will show you my example. My colleague and I, Vlaho, when we're doing this Love Stocks app, we say, okay, let's not complicate things too much. So we would only use Rx for fetching the data inside of the interactor, and then we will return the results via closures or callbacks. And this is horrible, because then it's like you're using super thing to solve one problem here, but then again, there's no way you cannot cancel this, you cannot do throttling, because you have closures, you cannot do anything with them. So I think if you go, it's better to maybe go all the way, because then it kind of, everything kind of fits to place nicely. You know, you have input from the user, which you transform, create a network request, and then bind something back to the UI. I will kind of show you that on the example.
But still, in that case, it still sounds like VIPER would be overkill.
Yeah, we discuss about this. I don't know, actually, I kind of love the idea about Rx and VIPER. It really makes code cleaner. But as I said, if your app is, if it will not be that like a big application, then it's definitely overkill. Because you know you have like this, before you had one file, now you have 4 files, and you need to kind of think, okay, what if I need something from here, there, it gets messy.
Not as much in number of files, but in number of signals you'll have to create in your code, because...
Not so many, you will see in my example.
Okay.